As we continue our work in geometry, what we want to do is look at some particular measurements that we can take with shapes. So in this video, we're going to look at calculating perimeter and area for various polygons. So a polygon, it's just a two-dimensional figure, meaning you can draw it on a flat piece of paper. We'll look at three-dimensional figures, but with that, we wouldn't be looking at perimeter and area, we'd be looking at volume. But with perimeter and area, we need something two-dimensional. And then what makes it a polygon is all of the sides of this figure are straight lines. So with that, some examples of polygons that we'll be looking at is you could have a square, a rectangle, triangle, really any shape as long as the sides are straight lines, that would be a polygon right there. So with a polygon, there's kind of two components to it. With each of those shapes that I drew, we could think about measuring along the outside of it to kind of see what's the length that's covered along the outside, as well as, which that'll be our perimeter, as well as what's the area being taken up by the middle of it. What area does it cover if you had kind of a grid over it, or some sort of square measurements. With that, we can also find that with polygons. So perimeter is the distance around the object. So say we have this triangle here. We can imagine as if I wanted to look at perimeter, I would want to take this side length, whatever that measurement is, plus this side length, plus this side length here. So what you can imagine is, in terms of measurement, imagine I had a piece of string or yarn and I started measuring here, and I just laid the string along the outside, along the outside, and along the outside until I looped back to where I started. The idea is that then you could take that string and just lay it flat on a surface, and then with that you could take a ruler to it and measure how long is this piece of string that would go all the way around. So with that, when you get perimeter out, it's just a distance, and you could think of that also as length. It's like the length of that string that you would need to go along the outside. So with that, in terms of measurement, in this section we'll be dealing with units of measurement, and with that we need to make sure we're using the correct form of the units. So the idea that this could be a string laid down and we just take a ruler to it, it's like we'd measure something in inches or feet or centimeters or whatever we're using. So with that, the units you'll be seeing for perimeter, and really you'll just copy whatever measurements are along the outside. Like if this was in feet, then your overall perimeter would also be in feet. If it was in inches, you'd have something in inches, maybe centimeters, meters, a form, but basically whatever distance you see along the outside, the units will stay the same as the perimeter. Then another piece we could think about is area. So this is the measure of the region inside the object. So what you could think of is a grid of some sort, like I drew over here, and putting your shape on top of that grid. So I have a triangle again here, but it's the idea that I want to look inside here and see, in this case with these squares in the grid, it's like how many squares are used to make up this region in the middle there. And with that, we'll have formulas instead of actually counting squares, but that's what it comes down to, is figuring out how many squares can fit inside. Now with this, if we're using squares to count, and it depends on the units that we're using, but it's like I'd have however many and then square units. So when we get to area calculations here, if our original measurements, like in this case, if that side length was given to us in feet, when you get area out, your units will be squared. So it'll be like feet squared, or square feet is how you could write it also. Either way is fine. And if it was in inches, you'd have inches squared, or centimeters squared, or meters squared. The key is that with these two forms of measurement, perimeter, units stay the same. When we take area, we're going to have units squared. So we just want to be careful of that so that we're using the correct units. So let's look at some formulas that we'll be using. So with a square, so a square is a quadrilateral where all sides are the same length. So you can see that with the tick marks here on it, that's just saying whatever one side length is, all of the other side lengths are the same. So if you imagine having these side lengths of S here, and they're all the same measurement, if you're taking the perimeter, you would just be taking S plus S plus S plus S. That's really what we're doing here. But for short, for a quick calculation, you could take 4 times S and you'd get the same thing out. Now to figure out the area, we would take S squared, or that's the same thing as taking S times S. So multiplying that would figure out how many square units would fit in the middle there. So for an example, let's say I gave you a square and said that one side is 3 inches, and then if you had one side, you could fill in the others and the units would all be inches as well. So for perimeter, you could just add up 3 plus 3 plus 3 plus 3, or if you wanted to use this kind of shortened form, that's great too. But numerically, we'd have 12, and then we want to be sure to include our units, which is just inches, since we're just adding those up. And then for area, we want to take the side length times the side length, or you could think of that as the side length squared. So we'd have 9, and because that gets squared there, our units would be squared as well. So we'd have inches squared, or if you wanted to write 9 square inches, that absolutely works as well. So that's our square. Rectangle, very similar idea. It's just with a rectangle, you have width and length. So we can call this width, and this would be length. And then you have these same side lengths, so this would be width over here as well, and this would be length over here. So in terms of perimeter, you can just add up along the outside. So length plus width plus length plus width, same thing. I can write that out here for you. Or for a shortened form, 2 times W plus 2 times L also works great. And then for area, like up above here where we took side length times side length, similar idea, it's just now we have 2 different measurements, so you take the width times the length. So, for example, if we had this rectangle here, so for perimeter, and you could kind of fill in the other sides based on our rule of having equal side lengths there. Perimeter, again, you could just add them up, or if you wanted to try out this formula, 2 times the width, which is 2 feet, plus 2 times the length, which is 3 feet. So that'll be a 4 plus 6, so this would be 10, and then you just copy the units because it's a length of measurement. All right, and then for area, we're just going to take the width of 2 times the length of 3, so that's 6. And then with area, we square our units, so it'll be feet squared, or again, you could say square feet, and that works great too. So that is our square and rectangle. Another shape we could deal with is a triangle. Now with triangle, it comes down to measurements of base and height, and our triangle can look different. So sometimes the height is an actual side length of it. The key is that the height has to make a 90-degree angle with the base. So that's what's making this the height right now, is that if we determine this is our base right here, then the side length that forms a right angle makes the height. But sometimes it might be hard to see the height if we just have this outline here and we call the bottom here the base. Then you need to think about this line that would drop down. Even though it's not an actual side length, the height of the triangle's coming from that perpendicular line falling down to the base. So you'd want to start at the vertex up there and then drop a perpendicular, and that would be the height. And then there's this third kind of strange case where the height isn't actually inside of the triangle, but it's still this measurement of here's the base, here's that vertex, dropping the perpendicular. It's just we have to kind of think outside of the triangle. but overall this distance here represents the height of that triangle. So for height, just make sure you have that perpendicular line falling down. There might be questions where Pythagorean theorem comes up in here because there are some right triangles, so you might have to solve for height, and you can use the Pythagorean theorem to do that. All right, so for formula, for perimeter, and really this is the rule for perimeter for all cases, it's just square and rectangle have some special simplified forms that you could use. But really with perimeter, what you're going to do is just you'll have the side lengths along the outside and add them up. So that's what you'll do for perimeter, is just add up the side lengths. For area, we're going to take 0.5 times base times height. You might see this formula a few different ways. Most often we say 1/2 times base times height. I put the 0.5 there just because sometimes that's easier, or most often it's easier to plug into the calculator that way. You might also see this as base times height divided by 2. Those all do the same exact thing, it's just different forms of the same formula. If there's formatting of it that you prefer, absolutely use the one that works best for you. All right, so with an example of this, let's say we had a right triangle with these 3 side lengths here. So for perimeter, all we would do is add them up. So I'll take that base of 3 plus 4 plus 5, which will be 12. And then the units just stay the same, so that'll be meters. For area, we're going to take 1/2 times base times height. And when you have a picture like this, it might be helpful to label. Like this would be our height, since that's making the perpendicular. This is at the bottom of the figure, so that would be the base. So you know what plugs in where. Order wouldn't really matter, but what you want to be careful of is not using that third side length that isn't part of the perpendicular. All right, so numerically, this will calculate to 6, and then we'll have our units of meters squared. So that's our triangle. And then this is a parallelogram. So what makes it a parallelogram is it has 2 sets of parallel sides. So what we have here is, what you could see is there's this side over here, and you can imagine that line carrying on. And if you look opposite of it, this line is running parallel to it. Parallel, and it's the same length as well. That's part of the parallelogram. So these are the same length here, and if those lines continued on forever, they would never intersect with each other. Same thing for up here. We have this line going across and this line going across, and if they continued forever, they would never intersect, and those sides are the same length as well. So that would make it a parallelogram. In fact, in this case, they're gonna have, this case they drew, no, sorry, never mind. I kind of made the notation look like all 4 were the same lengths, but they shouldn't be. We should have 2 different lengths coming through. Now, some labels that we're gonna need base and height, and it's gonna be similar to how we talk about them with triangles. So we'll just call one of these side lengths the base. And then what we need is a perpendicular line that falls from a vertex down to the base. So we have these 2 vertices. We could use this one on the left-hand side or this one on the right-hand side. Either way works, it's just a matter of the height falling within the parallelogram versus outside. So over here, it's kind of easier to see. If we drop this line down and have our 90-degree angle, that length there would be the height. We could see it on this right hand side too, it's just that we'd have to stretch outside, but it's the same length there. But what's nice about this image here, I know it's getting a little confusing with all these pictures, but this starts to show how we really do have a rectangle. It's just kind of tilted. The triangle that's showing up over here on this right hand side outside of the parallelogram, that triangle is exactly the same as this triangle over here. So you could imagine as if we had scissors and paper, if we cut out this triangle on the left-hand side and just moved it over here, we end up with a rectangle where we have this width that's the height and this length that's the base. So that's where our formula over here is exactly what you see for a rectangle, width times length. They're just using the terminology of base times height, but they end up being, in terms of area, the same shape. So perimeter, you'd add up the sides along the outside, and then for area, take base times height. So for example, over here, if we have these side lengths given to us, so for perimeter, we have 5 feet, 2 feet, 5 feet, 2 feet. So with this, what we can do is just start adding up. So 5 plus 2 plus 5 plus 2, or you could even use that shortened form from the rectangle, but that should be 14. And then we'll just copy our units of feet. And then for area, base times height, so you'll take 5 times, and then for height, just be really careful. Don't use the side length. You want to look at that perpendicular line that's falling in the middle of the parallelogram, so we'd use that 3 feet. So this would be 15 feet, and then should be squared. So that's our parallelogram. And then our last one that we're going to look at is trapezoid. Now a trapezoid has one set of parallel lines. So what we can see in our picture here is the top up here and along the base down here, those are parallel lines. 2 different lengths though, and then the other side should not be parallel. That's what makes it a trapezoid. So you have one pair that's parallel and one pair that's not parallel. They should intersect with each other if those lines continued on. So the sides that are parallel, we call those both bases. So along the bottom here, and actually it doesn't matter, we would just call both bases, but then what we use is a little subscript of a number to just show that they are going to be different lengths. So I'll just call this base 1, base 2. It doesn't really matter which order you go in, as long as they're different. And then what we should also have with a trapezoid is height, which will be a perpendicular falling down to a base. So again, you take a vertex, drop a perpendicular line down, and that would get you your height. So for perimeter, add up along the outside. And then for area with your trapezoid, you're going to take 1/2 times height times, and then make sure this calculation's done first. Base 1 plus base 2. Keep in mind your order of operations. I'll emphasize that. I'll show you how it would simplify step by step with our example. The common mistake here is to get those out of order, and it would mix everything up. You might also see this formula as h times b1 plus b2 over 2, and that absolutely works as well. Just whichever form works in your head is great. All right, perimeter. Just add up along the outside, so I'll take 5 plus 3 plus 4 plus 2.5, so 14.5, and then I'm using centimeters there, so that would also be centimeters. And then for area, so we're going to take 1/2 times the height, which is the 2 centimeters, so I look for that perpendicular line, times, and then base 1 plus base 2, and this is where I look for my parallel lines, so 5 and 4 are my parallel lines. So in terms of simplifying step by step, I mean, at this point you can just type it into a calculator, press enter, and get the answer there, and that's fantastic. But just to show you some of the process if you did want to simplify step by step, so we'd want to take care of the parentheses first. So order of operations, parentheses are first. So what we do is we could just keep everything else the same, but then 5 plus 4, so really we have a 9 there. So type that into the calculator, or if you wanted to do even more step showing work, we have 1/2 times 2, which is just 1, times 9. So you should be getting an area out of 9, and then centimeters squared. So that's how you would simplify it, but if you were at this first step and just went to the calculator and got the answer out, that's plenty of work to show as well. What I essentially want to see in your written work would be applying the formula, and then If you just go to your calculator, that's fine, or just take whatever steps you need to get to that final answer. But that's perimeter and area for some various polygons.